Hello, everyone, and welcome to today's One Key Idea session on testing challenges we failed to solve in the 2010s and how to solve it in the coming decade. I am Rex Black, sporting the RBCS t-shirt today because it's kind of a holiday period here, but generally you probably see me in a suit if you've seen me at a conference, or at least a tie. I'm president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. For 25 years now, since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. Now, if you have any questions throughout the course of the webinar, you may submit them at any time, but please note that they're only answered at the end. So let's get started. What is that big challenge that we did not successfully overcome in the 2010s? Well, this may come as no surprise to a number of you. For those of you who read my book in Managing the Testing Process, the third edition, which is the one that came out in late 2009, so just on the eve of the 2010s decade, I wrote that the failure to integrate testing best practices into Agile was a challenge that we need to solve in the 2010s. I wrote a little bit more than that. That's kind of the summary version of my discussion about Agile in the chapter towards the end of the book on life cycles and testing within the life cycles. So I wrote that, and I at that time had some hope that we would get there, that we would make steps. In my role at that time within the ISTQB, we were starting to think about how to discuss that process of integrating testing best practices into Agile, and eventually I even led a working group that produced the second most successful ISTQB syllabus, which is the Agile Testing Foundation, second only to the foundation itself. And so, yeah, in the early part of the 2010s decade, it looked like we were going to get there, but guess what? Though we've made progress, we certainly have not fully solved the problem. So here are my thoughts. 6 steps that we could take that actually would solve the problem. Try to be succinct yet concrete about these steps. So the first one is, it is the first one, I think justly so. There's really not any particular order to most of this list, but I think the top one is certainly the one that we need to focus on the most. So one of the things that has happened, thanks to Agile and thanks to open source tools and thanks to the whole idea of delivery pipelines and so forth, is developers are really into testing, especially automated testing, and particularly automated testing, and especially automated testing that gets integrated into the build and delivery pipelines. They can really geek out on this stuff, and justly so, because it is pretty cool to think about how far this has come. I mean, I remember in the 1990s, early 1990s, we had a automated build and test and delivery kind of system set up for our test environment. And we had tests running overnight as part of that automated build, and then deploying into the test environment. And we thought that was pretty snazzy, but that was all hand built. And these days, this stuff is just available. You download it, you set it up, there's books that describe how it works. It's fantastic. And you get developers who are, really, as I said, geeking out on this, and they are using tools to measure code coverage, and that's all great. And they're using static analysis tools, and that's all great. I'm a big fan of that. But one of the things that you find when this happens is that the automated tests that the developers are creating and putting into these pipelines aren't anywhere near as effective as people had hoped. And so what's happening there? What's missing? Well, what's missing is testing skills in developers. I can write a bunch of tests, and if I don't think about what I would consider sort of the one or more of the big 5 test design techniques, right, which would be equivalence partitioning, boundary value analysis, decision tables, state-based tests, and pairwise or combinatorial tests. If I'm not applying one or more of those techniques when I'm sitting and thinking about how to build out a set of tests, it's a pretty good bet that I'm not going to build out a effective and efficient set of tests. I'm going to have redundancy where I'm testing things are actually in the same equivalence classes multiple times because I'm not aware of how equivalence classes work. And then there's also things that equivalence classes, again, because I'm not aware of how they work, I'm not covering them, or I'm not adequately testing for undesirable combinatorial effects, or I'm not testing for desired combinatorial effects because I haven't thought through all the business rules and encoded them in a decision table. So getting developers to become better testers is, I think, key because, you know, this phrase shift left has become sort of a mantra. And the thing that's interesting about it to me is it's a mantra again. I worked on a project in the 1990s, the mid-1990s, with a client that was the unofficial logo or slogan of the project. It was shift left, and it was all about how we move the point of discovery and repair or elimination of defects closer to the point of introduction. You know, it was all we were focused on. And this is the same thing, the same concept now. Shift left has that same meaning. But if the developers don't have the skills to increase the effectiveness and efficiency of their tests, since they're really on the first line of defects that are introduced in code, then, you know, that's why they are going to need these skills. Now, I get that there are also defects introduced in requirements and design, and according to Capers-Jones's studies, that those 2 categories account for 45% of defects, while coding defects only account for 1/3. But still, 1/3 is a lot, and without saying anything about the, putting down the need to do things like good user story refinement and other forms of requirements and design reviews that are available and obviously are necessary, the developers being able to do good unit tests and support automation through techniques like BDD and so forth is really critical. Now, the flip side to that coin is increasing the technical skills in testers. Because automation has become so important and automated tests integrated into build and delivery pipelines are so promising, but often underutilized at the system level, testers really need to know how to exploit those techniques, and that requires having technical skills. Testers also can play a key role in participating in things like not only user story refinement sessions, but also code reviews and evaluation of unit tests and evaluation of static analysis results. And they can do those things if they have the expertise to participate effectively. The problem is that many of them do not. Now, this has changed over time, but it still remains an area where testers are not as strong as they need to be. So if you're listening to me right now and you're a tester and you're a non-technical tester, please go out and figure out how can you get more technical in 2020. Simple, start with a scripting language, learn Python. Python is the most popular, according to Stack Overflow, which we checked last year as part of a project. It is the most popular, fastest growing computer programming language out there. And it's a scripting language, which is great. So you can learn just basic scripting with Python. And then you can build on that because Python is also includes object orientation. So you can dip your toe into the object orientation area with Python and start to get your head around that, and that will position you to be able to move on to a full-blown object-oriented programming language, such as Java. And now you're speaking the language of your programmers. And so there's all sorts of books out here to help you do that. So I would suggest get started there. As you get into learning about scripting and programming, then you can start to participate effectively in terms of things like code reviews and understanding static analysis, and it will just really open your eyes as a tester as you start to understand how this stuff works inside, and also how it doesn't work. When failures occur, you're going to be much better positioned to help write up a good defect report, communicate with developers, those sort of things, if you understand how the technology works. I have a computer science and engineering degree from UCLA, and that technical background has been very, very helpful to me throughout my career as a professional tester. Now, moving on to another topic here, another solution, well, part of the solution. Pardon me, needed a drink of water there. It's a very dry, sunny day down here in South Texas. One of the things that we've seen happen is organizations that have adopted Agile, there's a big push towards shrinking down the duration of the sprints. You know, in early days, the 2000s, it wasn't unusual for me to encounter clients where, you know, they were doing 4-week sprints and were challenged to do that. And then over the years, the 3-week sprints became more common, and then the 2-week sprints became more common. And now I even have some clients that are doing 1-week sprints. Okay, I get that. I get the desire to do that. But one of the things that organizations have not gotten very good at doing commensurate with that all the time is making small user stories that can be implemented by the programmer in, say, a day. Now, why does that matter? Well, that matters because if you have a sprint, let's say it's a 2-week sprint, and I've seen this with clients, you don't make the user stories small enough, like a day of work, right? What ends up happening is you're not really fully engaging with the independent testers or testers who are ideally integrated within the sprint teams. So that's great. I see that. But then what ends up happening is the testers are doing other stuff, like looking at their automation and attending to other matters, environments and data and so forth during the first half of the sprint. And they don't actually even see running code and start executing tests until the last half of the sprint. And I've seen this be as dysfunctional as the last 2 or 3 days of the sprint. And this has the utterly predictable result of unearthing showstopper defects right at the end of the sprint when there's just no cushion left and blowing up the sprint. I've seen this a bunch of times, heard stories about this a bunch more times. Yeah, it's a real problem. So focusing energy on how to write smaller user stories, breaking down user stories into sub-stories, if you will, decomposing the user stories until they're at the point where it's a piece of code that the programmer can go off and write in a day, and testers can start executing manual tests against it in the next day. And if you're going to do that, then the other thing that's really important is to build in a risk-based kind of order. I haven't included that as a separate topic here because this would really be part of testing skills in developers, as well as, of course, testers having these skills. But the idea that things get built and tested in risk order is going to enable the discovery of the most important defects as early as possible. So shrinking the user stories and then building them in the right order so that the testers really are able to execute tests almost throughout the entire sprint against new code. Now, notice I'm talking about testers executing not only automated tests, but manual tests. And this is something that flies in the face of some of the dogma that's going around now, especially with respect to things like CI/CD, continuous deployment. This idea that we can automate all the tests and put them in our build and delivery pipeline, and if all those tests run, then everything will be great. So I have a long history of experience with this from well before I started my consulting company. My background was as a programmer. As I mentioned, I have a computer science and engineering degree from UCLA. And so as a programmer, of course, when I first got involved in testing, I approached the testing problem as a, surprise, surprise, programming problem. And what does that mean? Automating. And so for the early parts of my career as a test professional and test manager, I was heavily, heavily tilted towards automation. And in fact, with a couple of the companies I worked with as an employee right before I started my consulting company, my mantra was for quite a bit of that time, automate everything. Well, that worked out okay when what we were testing was operating systems, because the operating systems that I was involved in testing had APIs and command line interfaces, and you really could automate just about everything. Though there were certain tests, localization tests, so forth, that still had to be done manually. And then in the other job that I was at as a test manager prior to forming RBCS, I again tried to automate everything. And what I found, what I learned to my chagrin, was if you insist on automating everything as a manager, what you're basically telling your employees and the people who work for you and with you is, do not bother trying to run any tests that are not automatable. Nothing that is not automatable matters from a quality point of view. That is stupid. That is really stupid. I can say that's stupid because I've done it before, and it was stupid when I did it. It's possible that you might work in some sort of niche situation where it's not stupid for you. I'm not saying it's universally stupid, but it's most often stupid. And when I've seen it with clients and heard stories about it, generally speaking, this automate everything concept is not going to, in the long run, do anyone any favors. So we do need to maintain some amount of manual testing. Ultimately, automated testing is a form of verification. What I mean by that, remember, verification is verifying that the system conforms to specifications. That's the Phil Crosby definition of quality, conformance to specifications. And verification is important, but there's also validation, which is the J.M. Duran part of the definition of quality, which is fitness for use or fitness for purpose. So if you think of what an automated test is, it is basically an executable specification. It's a place where we have written down what we expect the system to do. And of course, we would hope that our specifications, for the most part, capture what it means for the system to be fit for use, but there is never going to be 100% coverage of fitness for use by the specifications. Now, there's varying explanations for that. Some of them get into computer science theory. I'm not going to go off into that tangent here, though. Someday I may do a webinar and explain what the difference is between verification and validation, which I did a short webinar on, but do a longer deep dive into why validation is always important. You can really never fully validate through verification. But anyway, just for the purposes of this short webinar, trust me on this one. So try to avoid that we're going to automate everything and that will be fine by itself mindset, because generally speaking, it's wrong. Okay, fifth step, including test-related criteria and the definitions of ready and the definitions of done in your sprints or other agile life cycles. This is really important. I can't say how many times I've had conversations with people where they're talking about code being done, and yet nobody's actually tested it other than the developer perhaps unit testing it. To the extent that you have test levels integrated into your sprints, your iterations, the completion of all the tests that are defined against a particular user story needs to be part of that user story's definition of done. And that user story should not count on the burn down chart until it reaches that level of definition of done. This is really important because from a metrics point of view, what gets measured gets done, and burn down charts are highly, highly, highly visible. And so if you want to make sure that people are thinking about successful completion of testing against all the user stories, make it visible when they have not. Make it visible through the burn down chart. The burn down chart is stubbornly stuck there, not converging towards the axis. And people start asking why. You get to say in the daily stand-up, because the tests are failing, because it's not passing the system test. This will raise the visibility of quality issues in the daily stand-ups, which is really important because the way the typical daily stand-up works, it's all tactics and how do we, and it's, what did we do today? What are we going to do tomorrow? What did we do yesterday? What's in the way? All that kind of stuff. It's all about how to get to that. We've done everything that was in the sprint. And by including the test-related criteria and the definitions of done, you make that front and center. Now, including test-related criteria and the definitions of ready is important too, because you want to make sure that code doesn't get handed off for higher levels of testing if it hasn't completed a unit test and hasn't completed a static analysis, right? Because then it's things getting tossed over the wall. And then finally, it would be nice if, well, let me back up. When the Agile Manifesto was first put together, there's only one person in that realm was a professional tester, and that was Brian Merrick. Brian Merrick was a professional tester at that time, having started off as a developer like I did, and he went back to being a developer. So you could sort of say that actually nobody who has flown the professional tester flag throughout their career was in that room. And it really shows. It really does show. It shows in a lot of the writings of a lot of the authors of the Agile Manifesto who clearly had not been exposed to testing best practices, but apparently have been exposed to testing worst practices in such a way that made them permanently disparage the need for testing as a specialty. Now, over time, as I've said, that has somewhat, we've seen some progress. I'm not going to say there's been no progress, but the fact remains that, people who are defining things like SAFe, the Scaled Agile Framework, which is really a dominant model out there, at least amongst the clients that I'm working with and talking to, testing as a special set of skills still remains underemphasized. And testing activities as unique, important activities remain underemphasized. In emerging things like DevOps and CI/CD and continuous deployment, the emphasis is just really on, again, automate everything and put it in the pipeline. There's not a whole lot of attention going back to the first bullet about, well, what's the quality of those tests that are being automated and put in the pipeline? So really getting this better nailed down is also going to be important, because otherwise we will be, as the cliche goes, the redheaded stepchildren of software engineering. And it's unfortunate because there had been in the 1990s a lot of progress made on building on what professional testing was about, and we've kind of gotten stuck. Agile has sort of gotten us stuck, and it's time that we, again, broken record here, say the same thing that I said in 2009. It's time that we get unstuck. Now it's interesting. Boris Beiser, who I consider one of the sort of three fathers of software testing, along with Bill Hetzel and Glenford Myers. Maybe throwing Dave Gelperin in there too. Boris Beiser died late last year, I think right around this time last year. Now, I was going back as part of some expert witness work I'm doing this year and rereading some of what Beiser wrote. And Boris, really was kind of the original SDET. And in his book, Software Testing Techniques, and also in Software System Testing and Quality Assurance, that really shines through. So it's kind of interesting that Agile and now DevOps have taken us to this place where Boris Beiser always wanted to see the testing profession go, or at least is positioned for that. But we're not yet exploiting that reality. And I think if we can get these 6 steps in place, we really will be in a position to kind of fulfill the vision of testing that Beiser had back in the 1980s, which to me, as I kind of close in on the last 10-ish years of my career, would be a very satisfying thing to kind of wind things up seeing testing end in the place where Beiser sort of wanted it to go, given that Beiser was my sort of entry into testing as a profession, or reading his books and thinking about what he said, and then having the incredible honor and benefit of him being a reviewer of managing the testing process, the first edition, and providing me with amazing insights back then, 20 years ago, 1999. So it really would be, I think, a fitting way for things to go here over the next 5 years, and kind of a acknowledgement of the prescience of Beiser's vision. So I hope we get there. I think if we look at these 6 steps and move towards these 6 steps and get this to happen, I think we've got a good chance. All right, I'm going to put up the advertisement here, as I always do, and then I'm going to go over and I'm going to see if I can't get the Q&A panel. Here we go. Q&A panel here. Get this guy over here where I can see it. Okay, so let me start. I got a question here from Nancy. Nancy says, okay, sorry, there's a little UI issue. I appreciate the advice regarding a good first step toward becoming more technical. I have been testing for about 20 years now, and I'm a functional tester. As technology changes, I am definitely feeling the need to learn more on so many levels. Do you have any recommendations surrounding good resources for learning Python? For example, online courses, YouTube videos, etc. So for me, the go-to thing when I want to learn a new skill is a book. I'm a very reading-oriented learner. I learn best from reading. This may be something that was trained into me at UCLA, because at that point, you know, we had textbooks and we went through a lot of textbooks. But anyway, I like that because I can go at my own pace. So I would recommend finding some books on Python, and I'm sure there are good ones out there. A main attribute to me would be that it includes lots of exercises that are worked through, so that you have solutions, and also gives you some advice on how to set up an IDE, an integrated development environment. I just went through and did a refresher on Java. I'm a C++ programmer by background, and the expert witness case that I'm working on right now uses Java as the language. So I had a book on Java programming that I worked through real quickly. I'm not going to plug it here because I don't want to get into that kind of commercial aspect of it. But it was a good book in that it had these 2 attributes that I was talking about. It had how to set up the integrated development environment so that you could get your work through the exercises, and then it gave a lot of exercises, and you know, that hands-on doing the coding is just really essential for programming. Now, YouTube videos. Well, online courses. I'm sure there are good online courses on Python. I'm not familiar with them, but we RBCS offer a lot of online courses on testing, so there must be good ones. Here again, I would say, you know, having the opportunity to do exercises and get help setting up the IDE is going to be really important. Now, YouTube videos. Now, you know, we, RBCS, have a YouTube channel. You can see the coordinates right there on your screen right now. I'm not anti-YouTube, but this idea that you're going to be able to teach yourself something as complicated as a programming language using YouTube videos, very skeptical. I had a client, a prospect come up to me at a conference once and say, we were talking about our Selenium training course, which also uses Python, and he was like, yeah, I'm not able to get any budget for that because we're just gonna have all of our testers watch videos on how to automate, YouTube videos on how to automate with Selenium and build from that. And I said, well, what automation experience do these people have? And they said, none. I said, that's just not going to work. The chances of that working are so vanishingly small. You're almost certain to just go down endless cul-de-sacs and bump your head, because it's not the kind of thing that you can learn in 5 minutes. You know, you can learn one little piece of it. Sure, you could have a video that explains how object locator works or something like that, but you know, knowing how to do good automation is a whole lot more than that. So nothing wrong with, you know, online resources of various kinds to, you know, reference manuals and so on, but do yourself a favor, don't trivialize how hard this is going to be to learn. Now, again, I don't want to scare you off. It's not that hard. And I know a lot of testers that get freaked out, like, oh my God, it's code, it's programming, I can't do it. You can do it. But don't make the opposite mistake of thinking, well, you know, this is just like, I don't know, making a chocolate cake or something like that. I can, so simple, I can watch a video of it on YouTube and follow along, you know, mirror what was done and everything will work out fine. No, programming is not like that. Okay, hope that was a good answer. Let's see, Scott says, what was the name of the man in the book that you mentioned? All right, so the man's name is Boris Beizer, Beizer. And the books, 2 books, Software Testing Techniques is one, and Software System Testing and Quality Assurance is another. And these are just kind of foundational texts in software testing. If you that, and Glenford Myers' book, The Art of Software Testing, and Hetzel's book, A Complete Guide to Software Testing, a vast percentage of the techniques and best practices that we still use to this day in software testing are explained in those 3 books. Now, I'm not knocking books that are more recent than that. Of course, I wrote my first book in 1999. I've written 14 books. I'd be happy if you read those too. But if you're interested in sort of the origins and some of the background, I think those are useful books, especially Beizer's books. So they are by no means a light lift. They are tough. They will challenge you, but if you invest the time in them, you will benefit from it. I got a question from Kayan here. Do you think testers should learn Java? If the programming language on the project on which you are working is Java, I think it would be great if you knew Java. Excuse me. If it's C++, I think it'd be great if you knew C++. Being proficient in the dialogue of the programmers with whom you are working is, I think, really important or really valuable. You can get along without it, but it's you know, if you've ever visited a foreign country where a lot of the population spoke English, but primarily amongst themselves, they spoke another language. You know, that's the disadvantage that you're at if you don't know the programming language being used on the project. Stefan says, do you have any techniques to prevent the mini waterfalls that you spoke about in sprints? Well, basically, I think that one of the big contributors was in where I've seen those mini waterfalls of code showing up at the end and blowing up. It's a lot of it has to do with the user stories are too big given the size of the sprint. They result in executable code only being delivered at the end. So I would say try to avoid that. The other thing that can help is, as a tester, having those technical skills that I talked about, because that allows you to engage while the code is being written. You don't have to wait until the code is done. Nancy says, thank you. I appreciate the insight. You are certainly welcome, Nancy. Travis says, as we enter into a new year / decade, what are your thoughts on AI / assistive AI and software QA? Great question, and I'll probably do a webinar on this in 2020, as that is clearly going to be a very important and influential technology. That said, I think right now we're just at the entry point of this. My organization, RBCS, we just put together a AI and software testing training and certification that we're going to be offering in 2020. And, I think that's an important kind of foundational thing. We are just at the entry point. As I said, I'll have more to say about this in 2020 as we roll out that training. Certainly it's going to be very important, and it's going to be transformative. The speed with which it's transformative, I think, is something that can be debated, because as is no surprise, there's a tremendous amount of hype. Travis says, thank you. I'm looking forward to the offering. You are quite welcome. And as I said, it'll be out in 2020. Look for information about that. Now, Paul, I've seen you are raising your hand and have raised your hand a couple times, but I don't know what for, because I really can only communicate via this Q&A panel. So if you can send me a question, that would be great. I've got some other email questions that I want to get to here. And then if I don't get any more questions coming in, I'll wind it down. It's pretty long for a one key idea webinar, but I guess I had a lot of interest. So one of the questions is, when you say testers should become more technical and developers should learn how to test, does that mean you are against specialization? No. Short answer is no. Longer answer is, I did in fact do an entire webinar on this, one of the old style hour-long webinars in defense of specialization, I think it was called. The thing, if you are building very, very simple stuff, simple mobile apps, simple browser-based apps, it may be possible for one person to have within their head all the skills that are necessary in order to be effective. But there's a whole lot of enterprise scale software that still needs to be built. And in that case, there's room for subject matter expertise, there's room for testing expertise, different kinds of testing expertise, performance testing versus functional testing versus accessibility testing versus a usability testing, for just to name a few examples. So I'm a big believer in specialization, but I'm also a big believer in trying to avoid tripping and falling into your silo and not being able to get out or communicate with other people. So the trendy thing is to talk about being T-shaped. And so, yes, I think that's where you want to go. So here's Paul's question. Any thoughts on model-based testing? That would blend your first 2 points. Model-based testing is something, Paul, that I hear a lot of people talking about, but I have yet to encounter a client that has successfully implemented model-based testing using any of the available tools, and it has been using that for 18 to 24 months or longer and is achieving a positive ROI. When I start seeing that happen frequently, I'm going to be a believer in model-based testing. Until I start seeing that happen, I will remain skeptical. There's a lot of things that sound really good and sound really promising that I run into as a consultant. Sorry, dry throat here. And certainly model-based testing is one of them. But and I'm a doubting Thomas on all things technological until I actually see them being successfully used by clients and with a positive ROI over a long term. Let's see. A couple more questions, we'll wind it down. My organization went to Agile, but we're not seeing the gains promised. Why is that? Is that just because testing isn't integrated fully? Well, no. There could be a lot of different causes for that, and I could do a whole discussion on stuff I've seen that has caused Agile implementations to be hobbled or to outright fail. But I think one of the things that kind of is at an overarching level is process as a way of solving software engineering problems has been overpromised from the get-go, going all the way back to CMM. this is an idea that comes out of total quality management, that if you get the process right, then the quality of the product will follow, and that works brilliantly for manufacturing and certain forms of engineered products. So, you know, if I'm building a bridge, I want to use I-beams, for example, that came out of factories where very carefully controlled the quality of the steel and so forth. And it's all done through process. Software engineering, we just ain't there yet. In fact, I did a webinar on this, which you can find, a recorded webinar out on the YouTube channel called Towards a True Form of Software Engineering, where I talked about what the differences are. And this was about 5-6 years ago, but it's still valid. I'll probably rerun it here because this is something that I think people fail to understand. And there remain big differences between manufacturing and software engineering and other forms of engineering and software engineering. Just to make this really simple, in manufacturing, they strive for what's called 6 Sigma levels of quality, which is only 3 defective items per million. So if you're running a assembly line that makes canned spinach, that's your target, is going to be three bad cans out of 1 million. There is nobody I know, or at least no client that I've worked with, or no credible stories that I've heard about organizations reliably producing software that only has 3 defects per million lines of code. And that might not even be the right way of interpreting 6 Sigma for software, because if you have 3 defects per million lines of code, well, those 3 defects are in every single copy of that code. So you actually have 100% defect rate or 0% good rate, because every copy of the code has defects in it. Unlike with the canned spinach example I just gave, you would have only 3 out of 1 million of the cans of spinach that would have any defects. But in this case, every single copy of a program that's installed has all of the defects that were in the copy that was downloaded or plopped in the CD drive and installed from. So we got a long way to go. And maybe when we finally get to software engineering as a true form of engineering, then we can see process improvements and getting the process right and so forth deliver. But until that point, I mean, I don't care whether it's CMM on the one hand and Agile on the other, and that the advocates of Agile will claim and proclaim loudly, well, we're not CMM and so forth. Yeah, but it's kind of like you're a different sect of the same religion. You're both worshiping the same God. The God is process as the way of solving problems. And yes, there are certainly significant differences between them. And you see this with the people who are like pro-safe and anti-safe, safe, SAF, lowercase e. You get very, very worked up over this, as is typical in this kind of religious warfare. But again, the underlying God being worshipped here is the same one. It is process. And so, I'm not a believer in that. I don't think we're there yet. Finally, the question: can you give an example of developers learning testing skills? Yes, we are actually working with a client right now, and we are delivering for them a 4-day course called Test Design with BDD, Behavior Driven Development. And the first 2 days go through what I referred to before as the big 5 software test design techniques: black box software test design techniques, equivalence partitioning, boundary values, decision tables, state-based testing, and combinatorial test design. And then the last 2 days are applying those techniques in the context of creating behavior-driven development scripts using the given, when, then, or Gherkin syntax. Taught to use the Gherkin syntax, and then to translate the tests that were designed using those big 5 techniques into the given, when, then, or Gherkins. And that seems to be working well. The client's happy with it so far. We're in the final pilot. Will happen in the next 3 weeks, and then we're looking to industrialize that and roll it out across all of their development teams. So certainly be happy to talk to anybody who is interested in something like that within their organization. But I don't want to make this a commercial, but I just want to mention that because this is a demonstration that you know, there are organizations out here that are doing it. All right, so that does it for the questions. I will wind it down with the usual closing here. Hope you enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. However, we do need to keep the lights on, and that involves paying clients. So if you enjoyed our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We don't expect to win all of your business, but we'd be honored to be given the opportunity to bid on all of your business. Happy to provide a quote for any such help you might need, and if it happens to be something we can't do, we will tell you that forthrightly. We won't waste your time with quotes that clearly won't meet your needs. So contact us at info@rbcs-us.com for more information on how we can help you. For information about free stuff that we give away, you see all of the coordinates here on the screen. So with that said, I wish everybody a happy holiday and a joyous and safe New Year celebration. And I will see you in the next decade.